Hey everybody, this is 7.1. We're talking about circles. So the whole point that well, I guess not the whole point why we're doing circles, but our topic this uh, unit is systems of equations. And you've talked about systems of equations before. It's like basically if we had a graph, like this is a linear equation, maybe we had another linear equation, and where they intersect, that is that's what we're finding when we do systems of equations. Okay, you've done that before, and what we're going to do is we're going to add that with quadratics and also circle equations. So that's what we're going to talk about first is equations that make circles, and then in 7.2 and 3 we will solve systems by graphing and by substitution. So a lot of this is, some of this is new, some of it is review. So please, if you have any questions, let me know. All right, so circles. First, let's kind of talk about like where does that come from? How do we come up with an equation that makes a circle? All right, so let's start by first finding the distance from this point that's on the right side, this blue point, to the origin. The origin is the center, or the 0, 0, okay? So we basically want to know what is this length, is this distance. All right, so in class I asked people, so how do we come up with that? And in every class people came up and said, oh, we could use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And I was like, well, don't we use the Pythagorean theorem when we have triangles? And we don't have a triangle here. But obviously this can make a triangle. We have a vertical line, we have a horizontal line, and then we want to find what the hypotenuse is, the longest side. So just remember when we're doing the Pythagorean theorem, A and B have to be the legs of the triangle, like the horizontal and vertical lines, and C has to be the hypotenuse, or the longest side of the triangle. And this only applies with right triangles, meaning that this angle is a 90 degree. Okay, so we could say that A could be 3, and the height of the triangle would be 4. So we got 3 squared plus 4 squared equals c squared. So this would be 9 plus 16 is equal to c squared, and we'd end up getting 25 is equal to c squared. And then we don't want to know what c squared is, we want to know what c is. Well, that would be, we'd have to square root both sides, and we'd get c is equal to 5. So we know that this is 5. Okay? So if you use the Pythagorean theorem, we can kind of find that distance, or that hypotenuse that we're looking for. All right? So for number 2, we want to list all the coordinate points as possible that give you the same distance from the origin, meaning that the C would be 5. So how many different ways can we come up with that? And it says name at least 12. So there's 12 nice points that you could use. Okay, so we already did 3, 4. Okay, but we could also do it if it was like upside down. So we could do 3, negative 4. You could also do 4, 3. So if you plug that in for A and B, you would still get the same thing on the left side. Same as if you did 4, negative 3. We could do on the left side of our graph, so we could do like negative 3, 4. We could do negative 3, negative 4, negative 4, negative 3, and negative 4, oops, I think I messed this up, 3, okay? I didn't mess that up, I just put it in a different order. So these are all other values that you could plug into the Pythagorean theorem and still get c equals 5. Okay, there are 4 more that we've missed so far. Is if we did like 5, 0, negative 5, 0, 0, 5, and 0, negative 5. So those would also work. Like if you plug this into the Pythagorean theorem and said it's 5 squared plus 0 squared, that would still end up giving us 25 equals c squared, and we would still get c equals 5. Okay, so if we plot all of these points, I'll do that kind of quickly just so we can go on. But I'm plotting all of these points. Okay, and what is this? I think I messed something up. I did mess something up. I'm sorry. Let me fix that. So we got 4, -3. Here we are. I knew I was doing something wrong. Okay, so what shape does that look like if we were to connect all those dots? It makes a triangle, makes a circle. It makes a triangle. Okay, so that gives us a circle. Okay, so there is a strong relationship between the Pythagorean theorem, which is a squared plus b squared equals c squared, and the equation of a circle. The equation for a circle, instead of using a and b, we're using like x and y. So x squared plus y squared gives us r squared. And what do you think r stands for? Well, that's the radius. Okay, so if we use 3 and 4, that gives us that radius that is, 5. Okay, so that's the equation for a circle. But that only applies if it's up at the origin. Okay, so we're just going to kind of go straight to this point and then we're going to talk about it. So this is kind of what we've talked about so far. Number 1 says the circle is a set of all points that have the same distance from the center. So that's basically kind of what we did here. We drew all those points that were 5 from the center, and it made a circle. Number 2 says the equation of a circle comes from the Pythagorean theorem. That's a squared plus b squared equals c squared, which is the same as the equation for a circle, x squared plus y squared equals r squared. All right, but we add a little bit of that so that if the circle's not centered at the origin, okay? So our new equation is x minus h squared plus y minus k squared equals r squared, where h and k is the center. So when we first did our graph at the very top, the center was 0, 0. So if you plugged in 0 and 0 for h and k, we ended up getting x squared plus y squared equals r squared. But if it's not, then it's going to change. It changed it a little bit. Okay, that's why we have h and k. Let's kind of look at this example here really quick. Here, if we wanted to find this this distance, without just like looking at it and say, oh, that's 3 and that's 4, what you would do, or you may want to do, is we'd say, well, one of our points would be 1, 2, and the other point is 4, 6. And to find the point, or the distance between points, is basically we need to figure out, well, I guess basically we use the Pythagorean theorem, but we need to figure out what is this distance. Well, that is the difference between 1 and 4. So like that, like if we were trying to find A would be 4 minus 1. It's 3. That's what we had in our first example. And if we're trying to find the height, sometimes we call it as like, this could be like x and this could be y. It's 6 minus 2, which gives us that 4. So this is kind of what's going on here, is we're taking that y and we're doing the difference between them. Okay. Don't worry about it so much. If you have any questions, I can talk to you about it some more. But enough to suffice to say, this is our equation, and we're going to learn how to use that. Okay. All right. So go to our next page. We're going to find the equation, or we have the equation. I'm writing that again if you want to. It might be beneficial. Okay. And for number 5, it says identify the center and the radius of each equation. So one thing you need to notice, if we kind of just look at this, you may say, ooh, that looks very familiar. We had something that had x minus h and then we squared it. Okay, that's like part of what we wrote down for the vertex form. Okay, and when we had it in vertex form, when we took out this h, like if we were to take this out, we changed its sign. Okay, and it's going to be the same thing. Here in this equation, it's negative h, but when we take it out, it's a positive h. Again, the reason why there's subtraction is because we're trying to find that distance between the x's, and we're also trying to find the difference of the y's, because then we could use a squared plus b squared equals c squared. Okay, so here we want to find the center. I'm just going to call it c for now. Center is, again, here it's going to be negative 10 comma negative 5. The opposite of what you'd think, okay, because it's actually, this would be kind of like x minus negative 10, if that kind of makes sense to make that work. X minus negative 10, okay. But again, it's just, if you want to just keep it as, it's the opposite of what you think, okay? And then our radius, again, this 25 isn't the radius, that's the radius squared. So if we want to find the radius, we've got to square root 25 to give us 5. Okay? So here's another example. Our center is negative 9 comma negative 1, and the radius is the square root of 16, or 4. Okay? Why don't you pause? Well, I guess these are a little different, so maybe we'll talk about it together. Center, you can probably come up with that. It's 14 comma negative 8. And then the radius is, well, this again, this is r squared. We don't want r squared, so we need to square root it, and that's what you end up getting. Okay? This can't be simplified. It's not a perfect square. It looks like it's going to be close to 4, a little less, but that's all you need, is just write it as the square root of 15. And it can't be simplified. We can't simplify the root. This is very similar, so here we get c is negative 12 comma 6, and it has a radius of the square root of 13. This would be a center of 4 comma negative 13, and a radius of the square root of 5. This one you may want to notice this one when we get it's 2 comma 3 is our center, and the radius here is the square root of 1, and that's just 1. Okay? Alright, so you should be able to do that. Another thing you're going to be asked to do is to identify the center and the radius from the graph, and then also write down the equation. So if we look at this, the center is, in the center of the circle. If we write that as an ordered pair, that would be 0 comma 3. And then the radius, again, is the distance from the center out to the circle. It's easiest if you just go straight over or up or down or left or right. Okay? Don't try and go something like that. That would be very difficult to tell. Okay? So here we get a radius of 1. You may have thought it's 2, but this is going by halves. Okay? It's not going by ones. So this is 1. This would be a half and another half. Okay? So be careful with that. Here's another example. You should give this a try if you would. Looks like I didn't erase that all the way. So our pause if you would, give this a try. Looks like our center here would be negative 1 comma 2. And the radius would be 1, 2, 3, 4. Oh, and we also need to write down the equation, so I haven't done that either. Okay, so again, it's kind of hard to see, but on yours you wrote it down at the top. I'll rewrite it here. So x minus h squared plus y minus k squared equals r squared. Okay, so our center is our h and k, and we already have our r, so we just plug it all in. So we get x minus 0 squared plus y minus 3 squared equals 1 squared. But we know that x minus 0 is just x, and we know that 1 squared is just 1. Okay? Here's another example. We do x plus 1 squared, and then we'll do y minus 2 squared equals 4 squared, but 4 squared is 16. Okay. Alright, so we should be able to do that on a homework and test. Now we want to go the opposite direction. We have the equation. We want to write down the center, radius, and then graph it. So the center here would be 0, 0. Okay. We don't see it here, but this would be like x minus 0 squared and y minus 0 squared. So our h and k are 0 and 0. Our radius would have to be, so again, this is r squared. To get r, we'd have to square root it. So the square root of 36 is 6. So we'll plot our center, and then I want you to plot 4 points on your circle. And to do that, we'll just go up, down, left, and right. So up 6, over 6, down 6, left 6. And do your best to connect the dots, making a circle. Okay, here's another example. You could give that a try if you'd like, but our center is 3 comma negative 2. So 3, negative 2, it's right there. And our radius is the square root of 4, which is 2. So we'd go 2, up, down, left, right. Kind of missed that, but you get the idea. Alright, you can give these two a try. D, definitely we need to talk about that one. But why don't we finish this too? So the center is negative 4 comma 4, negative 4, 4, and it has a radius of the square root of 1, which is just 1. So this is a teeny circle. And then this one, our center is negative 3 comma 0. That would be like 1 minus 0 squared. And then our radius is the square root of 10. But what is the square root of 10? I don't know what that is. So what you're going to do is you'll put that in your calculator, and it will give you like 3 point, I think if you round to the the tenths place, then we'd do 3.2. Alright, so that's what you'll do, is you will plot that center, and you'll go over 3 and a bit, up 3 and a bit, left 3 and a bit, and then down 3 and a bit. Okay, so not quite 3, a little more than that. Okay, alright, so that's what you do if our radius is not a nice number. Alright, last thing we need to talk about is if we have a center and a point. So our center was always our h and k, and if we were to write this down, we'd get x minus h, so minus a negative 2, which will give us plus 2. And then we'll do add that to y minus k, which is the negative 3, so plus 3. And that's equal to our radius squared. But we don't know what the radius is. They don't give it. This is very similar to what we did in Unit 6, where we had the vertex and a point, or we had the x-intercepts and a point. So our point was always our x and our y. And that's the same for this problem. And we'll plug that in. So we'll get x is 15, and y is 2. And this would be 17 squared plus 5 squared, which I think is 314. And you'd use that, plug that in your calculator, and that's what you should get. I think I'm just remembering from what we did in class today. Okay, and we were missing r squared. So at this point we can just take this value and substitute it in for r squared. You don't need to find what r is. If you want to, you can. R is the square root of 314. But you don't have to. We can just plug that in, and our final answer would be x plus 2 squared plus y plus 3 squared equals r squared, which is 314. Okay, and we're done. All right, if you want another example of that, we'll do B, I guess, really quick. So again, this is our h and k. So we would get x minus 1 plus y minus 0, well that's just y, equals r squared, but we know what x and y are, so we'll get 10 minus 1 plus 15 minus 0 equals r squared. Looks like that's 9 squared plus 15 squared equals r squared. And I think I do have my calculator. So 9 squared is 81. No, turn it on. Alright, hang on one sec. I need to get a different calculator. Alright. Okay, so 9 squared is 81 plus 15 squared. So I think we end up getting 305 if I did that right. So we can take that 305, plug that in, x minus 1 plus y squared, again y minus 0 is just y, equals 305. Okay? Oops, I think I messed that up. I think it's 306. Yes, 306. Okay. Sweet. Okay, so that is that. The last thing that we can talk about is like number 9, where the center and radius is given. So that's like the opposite of these ones where I give you the graph and you write that stuff down. Here I give you the stuff and you write down the equation. So we have x plus 3 plus y minus 2 equals the radius squared, so 36. And you got it. Okay? Alright, so that's it. If you have questions, let me know. I'd love to help you. We'll see you later.